Hello everyone. Today let us talk about Bohr's postulates, the three postulates of Bohr's atomic model. The first postulate goes like this. Bohr's first postulate was that an electron in an atom could revolve in certain stable orbits without the emission of radiant energy, contrary to the predictions of electromagnetic theory. According to this postulate, each atom has certain definite stable states in which it can exist, and each possible state has definite total energy. These are called the stationary states of the atom. In simple words, what I can tell you is there is a nucleus in the atom. Around the nucleus, electrons orbit in certain orbits, and each orbit has a definite total energy. That much is enough, nothing more to worry about that. Each electron revolves in one of the orbits around the nucleus, and each orbit has a certain energy. That's enough. And then let's go for the second postulate. The second postulate goes like this. Bohr's second postulate defines these stable orbits, that is the stable orbits which we have discussed earlier in the first postulate. This postulate states that the electron revolves around the nucleus only in those orbits for which the angular momentum is some integral multiple of h by 2 pi, where h is the Planck's constant, whose value is 6.6 into 10 to the power of minus 34 joule second. Thus, the angular momentum L of the orbiting electron is quantized, that is, L is equal to nh by 2 pi. In simple words, what I can tell is all electrons revolve around the nucleus in certain orbits, and when an electron revolves around the nucleus, every electron has some angular momentum. Angular momentum means which we have studied in the rotational motion of the 11th standard. That is, whenever it moves around the nucleus, it has some angular momentum, that is mvr, mass into velocity into radius of the orbit. That angular momentum is given by the letter L. L is equal to nh by 2 pi, where n is the number of the orbit, that is n is equal to 1, 2, 3, 4, etc. So, L is the angular momentum of an electron, that is equal to L is equal to nh by 2 pi. And now let's go for the third postulate. The third postulate goes like this. Bohr's third postulate incorporated into atomic theory the early quantum concepts that had been developed by Planck and Einstein. It states that an electron might make a transition from one of its specified non-radiating orbits to another of lower energy. When it does so, a photon is emitted having energy equal to the energy difference between the initial and final states. The frequency of the emitted photon is then given by h nu is equal to EI minus EF, where EI and EF are the energies of the initial and final states, and EI is greater than EF. In simple words, what I can tell is electron sometimes jumps from one orbit to another orbit. When an electron jumps from higher orbit to lower orbit, energy is released. That energy released is equal to h nu, that is equal to EI minus EF, where EI is the orbit where it was in the beginning and EF is the orbit to which it jumped. So, suppose for example, if an electron jumps from fourth orbit to third orbit, then the energy released is energy of the fourth orbit minus energy of the third orbit. Suppose if an electron jumps from fifth orbit to second orbit, energy released is energy of the fifth orbit minus energy of the second orbit. That's all simple. That is equal to h nu, where h is the Planck's constant, nu is the frequency. Okay. By this time, I hope you got the idea about all the three postulates of Bohr, which are very important for you. Thank you. Thanks for watching. God bless you all and grant you all great success in exams.